What you need?
Stacks on stacks on stacks.
B-Kash.
Stacks on stacks on stacks.
We got
Stacks on stacks on stacks.
I got
Stacks on stacks on stacks.
She got
Stacks on stacks on stacks.
They got
Stacks on stacks on stacks.
Got calculus going so long, this test right now so hard. Can't afford to do this wrong. I left this problem start on the volume between two curves, rotated around that line. I wish I sat by that nerd, I'm about to fall behind.
Stacks on stacks on stacks. 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 Gotta integrate these stacks.
Methods you can use, got dishwasher and shelf. You better follow well. Let's start out with the stacks. The rectangle we start, revolve to get a tube. Use like a Rubik's Cube. Draw a pick and you shall see. First we'll make a graph. Use a TI-83 plus. The area then you must rotate about that line. The volume you can't find by multiplying by 2 pi times the integral of h times p dy. Your h it is the height and p is your axis. Your integral has bounds from the area you have found. Here's the equation, 2 pi times the integration, bound from c to d of h times p sub y. Got calculus going so long, this test right now so hard. Can't afford to do this wrong. I left this problem start on the volume between two curves, rotated around that line. I wish I sat by that nerd, I'm about to fall behind.
What you need?
Stacks on stacks on stacks.
B-Kash.
Stacks on stacks on stacks.
We got
Stacks on stacks on stacks. Stacks on stacks on
I got
stacks. Stacks on stacks on stacks.
She got
Stacks on stacks on stacks.
They got
Stacks on stacks on stacks. Gotta integrate these stacks.
Yeah, the next one up on deck is the volume using disc. Again, we draw a pick, the boundary region will revolve. And now what we shall do is sketch, reflect, revolve, and find the radius, which this ain't nothing new. Now determine the limits, both upper and lower bounds. Use the info we have found to set up the integral. The radius is from the line out to the curve, and the limits bound the area of which we did revolve. To the volume now we go. It's a simple equation involving integration and set up just like this. The integral from a to b of the radius function squared and multiplied by pi. Now you're done. Now high five.
Got calculus going so long, this test right now so hard. Can't afford to do this wrong. I left this problem start on the volume between two curves, rotated around that line. I wish I sat by that nerd, I'm about to fall behind.
What you need?
Stacks on stacks on stacks.
B-Kash.
Stacks on stacks on stacks.
We got
Stacks on stacks on stacks. Stacks on stacks on
I got
stacks. Stacks on stacks on stacks.
She got
Stacks on stacks on stacks.
They got
Stacks on stacks on stacks. Gotta integrate these stacks.
This last method is new. What are we supposed to do? The solid has a hole. It looks just like a bowl. The volume we will find will have two radii. Outer one identified, the smaller one's one inside. The outer's big R of X, the inner small R of X. These labels we will see in an integral A to B. A to B are found where the functions intersect. Now we will double check. All is found, now we are set. So first we square big R, and then square the small one. Subtract the big from small, that's the difference of R's squared. The volume's equal to pi times integral, bound by A to B of the difference of the R squared.
Got calculus going so long, this test right now so hard. Can't afford to do this wrong. I left this problem start on the volume between two curves, rotated around that line. I wish I sat by that nerd, I'm about to fall behind.
What you need?
Stacks on stacks on stacks.
B-Kash.
Stacks on stacks on stacks.
We got
Stacks on stacks on stacks. Stacks on stacks on
I got
stacks. Stacks on stacks on stacks.
She got
Stacks on stacks on stacks.
They got
Stacks on stacks on stacks. Gotta integrate these stacks.
Yeah, B-Kash from Calc PC.
YC.
Hey yo, it's your boy T Stacks in the building.